Hello guys, so today we'll be doing a new part of similarity. Basically, we have already known what are similar triangles. Now we are going to do something that is called similarity and area ratio. This part is basically not much of mathematical, but it is more of practical, because this kind of transformation of areas, we call it transformation of areas, are very useful in doing various practical problems, and we can implement many practical live engineering marvels from small things. Okay, so what is basically it? First I will like to explain that. Suppose you need to make a building which is say 20, ठीक है, 20 तला का बिल्डिंग बनाना है आपको. So in that case, you want to show somebody the structure of the building. So what, that too in a normal table. Okay, you want to show the structure of the table. Now if you see this one, then how would you show this 20 tala building on a table? Is it practically possible? No. So what you do is you make a small model of this 20 tala building over here, and when you make the small model and show it to your clients, customers, or your boss or your teacher, then he or she gets an idea about the intricacies of the building, and he he or she gets an overall idea of your work that you are going to do while you make this building, correct? So that is very important while we talk about practical things. So in real estate, this kind of area transformation is very important. Okay, now let us understand what does this area ratio and similarity means. So if you see, there are two triangles over here, ABC and PQR. So what I wanted to say is that suppose this angle is equal to this angle is equal to this angle, and obviously the last one, this angle, will be equal to this angle. So in this case, these two triangles are similar. So I can write triangle ABC is similar triangle PQR. So now if somebody asks you what is the ratio of the areas of these two triangles, there are certain simple relationships that can be developed. So if I want to write it like this, area of ABC by area of PQR will always be equal to the square of the ratio of corresponding side. The square of the ratio of the corresponding side. Okay, so you can go through any of the normal textbooks. We generally follow, or we advise everybody to follow at first book of ML Agarwal. So there the theorem has been proven, and you can easily understand why this relationship has come. Our main motto is to use this relationship and solve different problems. Okay, that is our main motto. So this is one of the theorem that we are going to use. So basically area ratio of the two triangles will be the square of the ratios of the corresponding sides. Now we'll study about maps and models. Suppose I draw a map like this. Now obviously the map is not of the size, is the map, not of the size of the actual area that I am showing now, because if you see a map of India, that definitely isn't of the size of the actual Indians of India as a country, right? So it is basically drawn to some scale. Suppose in case of maps, a map is drawn to a scale of 1 is to k. Okay, so if the map length, suppose this is the length of the map, is obviously the map and the actual area is similar, right? So if this part is 1, then the actual length of this part is k. Okay? So in this kind of cases, the length of the actual figure is k into length of the map. Length of the actual figure is k into length of the map. Okay? And what is the area of the actual figure? Area of the actual figure is k square into area of map. Okay? So this is very important. This is in case of maps while we are talking about 2 dimension. Now if there is something called model like this, there is a big cube which I am going to show in a smaller dimension. So you can see this is a cube. Now suppose there is a lot bigger cube than this, and I just want to show a model of that like this. So there is some length over here of the model. Now if suppose the model is made at a scale of 1 is to k, that means if the model is having a length, or here it is height, as 1 centimeter, the actual cube, which is much bigger, will have k centimeter. So in this case, the length of the actual cube will be k into length of the model. Similarly, area of any portion which is from the actual will be k square into area of model. And if you want to calculate the volume of actual one, will be k cube into volume of the model. Okay? So if you want to calculate the actual size, then you have to multiply k cube. If you want to find out volume, you have to multiply k cube into the volume of the model. Okay? If you know what is the scale ratio. Let us take this problem which has been asked in ICC 2000. There were 2 areas given. One is the area of this trapezium BCED, and another is the total area of the triangle ABC. It was also given that DE is parallel to BC. So if DE is parallel to BC, I can easily say that this angle will be equal to this angle, corresponding angle, and this angle will be equal to this angle. So you have to write all these things. As soon as we have equated these two angles, so that means I can write triangle ABC is similar to triangle ADE, right, from AA theorem of similarity. You have to write completely, okay, angle theorem of similarity. Now I can now easily say that area of ADE by area of ABC is equal to DE square by BC square. Now do I know what is DE? Yes, 14 square by BC square. Do I know what is the area of ADE? I don't know, but ABC I know, so 25. And what is the area of this part? The total area is known. The total area of ABC is known as 25 centimeter square, and the area of BCED, that means this portion, is known to me 24 centimeter square. So this will be 1 centimeter square. Okay, so I can write it as 1. This will be 196 by BC square. So from here I can calculate BC, right? 25 into 196, that is 5 square into 14 square. So what is BC? BC is 5 into 14, that is 70 centimeter. Okay, so see, this kind of problems are asked. I have directly used the formula that area of two triangles, similar triangles, are in the ratio of their corresponding sides, right? Square of their corresponding sides. So that was it, nothing else. So I have solved the problem right now. This type of problem has been asked many a times in ICSE examination. time and time again, so I have chosen this problem over here. So I would like you guys to try one by one. So as we have taken the first class today of this maps and model part, so you can try first 10 to 12 problems. Okay, let's take 12 problems. Okay, so you will be trying 12 problems, first 12 problems of your book ML Agarwal. As soon as you finish 12 problems, we will again have a short discussion like this, and again we will go for the नेक्स्ट जितना भी प्रॉब्लम बाकी है, हाँ, दो दो पार्ट में तो हो जाएगा. देखो, समझने लायक चीज़ तो बहुत कम था, थियोरम पार्ट बहुत कम था. 10-15 मिनट के वीडियो में आपको मोर और लेस मैंने आइडिया दे दिया. नाउ आई थिंक यू शुड स्टार्ट डूइंग द प्रॉब्लम, एंड as and when we are facing any issues with doing the problem, then we can understand that what else we need to study, and what did we miss out really. We have covered the theory part. You try, and after that I'll interpret. Okay, thank you.